This is Mike Dubson. I'm going to tell you a little bit about the PhET sim projectile motion. In this simulation we have a cannon, and we can adjust the angle of the cannon, the initial speed of the projectile, as well as the initial height and horizontal position of the cannon. Let me give you a couple of examples of things I use this sim for during lecture to demonstrate physics concepts for the students. Let me set the initial angle of the cannon to 0 degrees and raise the cannon up to some nice tall height like 16 meters. I'll set the initial speed of the cannon to 10 meters a second, and let's fire the cannon and see how long it takes to reach the ground. Fire. That took 1.83 seconds to reach the ground. Now suppose I increase the speed of the projectile from 10 meters a second to 15 meters a second. I would now ask the audience, will it take longer for the projectile to reach the ground, the same amount of time, or less time than before? I would have the students discuss this among themselves before voting, and after they've voted with their clickers, then we'd answer the question experimentally by firing the projectile. So here we go at the increased speed of 15 meters a second. We want to know how long it takes to reach the ground compared to 1.83 seconds. So I'm firing again. It still took 1.83 seconds. I'll slow it down to 5 meters a second initial speed and fire a third time. Once again, 1.83 seconds. The point here is that the time it takes for the projectile to reach the ground is controlled entirely by the vertical motion and not at all by the horizontal motion. These black tick marks represent the position of the projectile at 1 second. So you can see 1 second after they're fired, the projectiles are all at the same altitude. They all fall down at the same rate. Another thing I like to use this simulation for during lecture is to illustrate the importance of air resistance. Let me put this back down to the ground, set the angle to about 45 degrees, and I'm going to set the initial speed to 30 meters a second. I'm going to choose as my projectile a football. Now let me back out a little ways. And let me fire the football. That was with no air resistance. I meant to do it with air resistance, so let me fire it again. So let's measure how far that football went when it was fired with an initial speed of 30 meters a second. It went about 65 meters. Incidentally, you can get the range either with this tape measure that I'm using, or you can read the range right off here in the top display. 65 meters is about 70 yards. That's about as far as a professional football quarterback can throw a ball. Now let me throw this ball again without air resistance. So let me back out. It went a lot farther, about 50% farther. The point of this exercise is to show that the reason we ignore air resistance is not because it's a good assumption, but because it makes the mathematics a lot easier. That's all for now. Thanks for using PhET.